Octave just talked about emulators, and I think we have a topic to deep dive. How emulators can accelerate your quantum technology adoption, because it's a tool running on CPU at this point. It's up to 20 qubits, I think. Maybe few of them can do better. We can go to deep dive that. First question for you. In your opinion, what is the role of emulator in today's quantum adoption curve? Maybe we can start with you, Maud. We are the last one that we deploy.
Okay, so you've heard we are now accessible in OVH Cloud. The emulator is called Clio. This is an emulator of logical qubits. And the idea is that we want to expose the ecosystem to logical qubits and start thinking gate-based applications. So that's on one hand, this is really the mindset, work on the use cases to drive the use cases and find new use cases. And it's really a way to speed up the adoption. We're also working on several releases on the emulator, and we will have emulator that describe also accurately the technology, with taking into account the noise, so that we can work on the full stack and having the way from the use cases all the way down to the compilation with the real description of the hardware. And I have to say that this is something that we've used in the past in the semiconductor industry to really accelerate the technology adoption, because we work concomitantly on the use cases and on the technology, so that when the technology arrives, everything is ready to adopt it.
Maybe Philippe, you can talk about QPerfect. You also just deployed on our infrastructure.
We are also, thank you, Fanny, for inviting us. And yes, QPerfect is a new kid in the block. We started the company 2023 with a Grand Prix iLab on emulators called Mimic, and we are now on the OVH platform. It is essential for adoption of quantum computers that the community start with emulators. As Maud said, with the example of Synoptics, Cadence, and CIS, etc., it is crucial to be able to have a in-ramp to the quantum world. And emulators are here for you, not only for education or for starting to program your first circuits, but also to modelize the promise of what would be a quantum computers. I'm sure we will talk about the different kind of emulators, but I would start with consider quantum emulators as your companion in your quantum journey.
Laurent, maybe you have a different approach of to just simulate the comportment of quantum computers. You are more on use cases. How you can describe what you do at Colibri TD and what type of emulators you can deploy?
Thanks, Fanny. The point is, at Colibri, we are at the end user level, application level. So we are the end user of the simulators, hardware, and so on to develop the application for end users. What we build, in fact, it's a quantum production chain. It's a DevOps aspect to quantum. We need to speed up quantum adoption, so we develop the application with the end users, and then we have cycle of deployment. You don't deploy on existing hardware resources. They are rare, they are difficult to use, so you need to have an intermediate step where you can test the overall chain and what you're building for your customer does work and can work. So that's really, so emulators are useful today, they are going to be useful tomorrow and the day after tomorrow. It's really the overall chain of deployment of your solutions towards the end user. That's what we do at Colibri. So in terms of emulator, we want to be agnostic to hardware in terms of final deployment. So we will use all, and we are using all emulators that people can provide to us. The more, the best for us.
Thank you. How do your respective emulation approach reduce the entry barrier for industry or researchers? How you can help them with that emulators? Laurent?
I mean, I'm using every day. I mean, my team can have a testimony about that. We intensively use emulators. I mean, the barrier to entry. I mean, you have. We develop a middleware to be able to basically completely abstract that to the researcher. Researchers are not developers. So they can't learn about everything. What they need to understand from emulators is the noise model, what kind of qubits, fidelity, and so on they have. So they need the high-level information of the emulator. They need to be able to understand the noise model and how they can apply it to it. That's it. The rest should be completely abstracted because they are not developers. They need to focus on the algorithm development.
Philippe?
I would add on what Laurent was saying that I totally agree. And we have, with Mimic, for instance, two kind of discussion with scientists. The first one is those who are developing quantum machines and how they can see their machine improving and use the emulators with their noise models, with their quantum error correction techniques. And on the other side, the industry coming with an example where they need to really have a robust emulator to imagine what the quantum computer would give them. So that's why when you were saying, Fanny, 10 to 12 qubits, it's really depend on the technology you are using. State vector, of course, can go to few tens of qubits, 30 qubits, etc. But when you are coming to tensor network emulators, you are going to be in the capacity to really go to the reach of a quantum utility. So really stress your algorithm and play with it. And I think in that sense, you help the ecosystem.
I wanted to stress something because maybe we didn't say our three companies are working together today, and we are getting inspired by QPerfect. QPerfect developed the heart of the emulator that we are providing, and Colibri uses what we're doing with QPerfect. And I wanted to take two examples to show you the interest of what we're doing. Currently, in the world of optimization, a lot of things have been done using analog quantum computing, but we know that gate-based quantum computing is potentially a disruption for optimization, and we need to think in terms of logical qubits and have the operation on these logical qubits. So this is what we can deep dive with the new emulator. And another example is that when we're going to design our logical qubits, you've all heard that there is an overhead in terms of logical to physical qubits. And this overhead strongly depends on the way we make the operations, on the way we design the logical qubits. And no matter how you put it, at one point you've got operations, and you've got operations, 1 and 2 qubit operations, and you've got a way to transfer the information. And there's going to be trade-off on how you actually implement those operations. And with an emulator that takes into account the specificities of the material, you can, of the qubits, you can actually have optimized machines before you do the hardware, and it really speeds up the development of the hardware. So this is something that our three companies are working on and are enabling in the advent of fault-tolerant quantum computing.
Do you want to comment?
I mean, she said it all. It's a team effort, and it's how the industry has to look at it. And you can also use after all the hub around it to help the three of us. Of course, you talked this morning about Maison du Cantique, or we have also a Three Nation project in Alsace called Hub Quantval, where this ecosystem has really to work together to propose it to the industry. We were hearing this morning some solution. I was listening this morning that we are missing use cases. There was one just here on the round table for all the industry to use. That's where I think it's wonderful.
I think what people are looking at as the end user perspective is, do you have something that shows some value to me? Maybe not today, because I'm completely aware that quantum computing is a deep tech, relatively mid-term. I'm not using long-term, mid-term vision. So how can I accelerate? and it's our responsibility to build the quantum DevOps chain, if we want, to provide solutions. People don't care what hardware you have. To be clear, do I use GPU? Do you use CPU? People at the end, do you solve my problem? Period. I'm really keen on paying, committing resources to your solution, but do you bring value, and how fast do you bring this value? Anything that can enable the development and the acceleration or come to solutions for solving business case is what we do. I don't agree on the fact that we like use cases. Just at Colibri, we just don't have enough people. I can name right away, or at least 10 use cases with potential of quantum in any technology. And we are only doing one specific thing, which is solving partial differential equations. So we have plenty of use cases because there's many of challenges. The point is how will we mature enough to provide that to end user in a very kind of digested way, like they have for GenAI. If we compare to GenAI, today you want to generate PowerPoint, you just click and you have something that generates PowerPoint, period. You want to generate a video, you click, you generate. You don't care how it works. We should reach the same level with all these technologies for quantum.
Yeah, it's to find the app killer of quantum that we decide all the clients. What do you recommend to companies who want to begin their quantum journey using emulators today or work with you? Maud, for example?
Actually, there are a lot of users club that already share knowledge, and especially in France, we've got the chance to have strong ecosystems. So I'm against ecosystem. Let's make it clear, because it's sometimes Paris against Grenoble, and it's kind of, it messes everything up. So everybody knows I'm from Grenoble, and we're fighting to exist. No, kidding. The fact is that there are some Maison du Quantique. You've got your entry points, so you can go to Maison du Quantique. There is TerraTech, there is Hub Quantique, and depending on which door you knock at, you will have a different accompaniment, but nonetheless, if it's not the one that is suited for you, everybody knows everybody. So we can just reorient you to the right guys, and you will get some support. And the emulators are really a very good entry point. We have currently this week built last week built a training to get people acquainted to quantum, to get used to use our emulators, and lots of hardware startups are doing that to build the ecosystem. We need the ecosystem, so we need a lot of people to get accustomed to the technologies. So I name how to get there. I know that there are people from all these places, Maison du Quantique, Hub Quantique, and TerraTech, and you can go to these places and get some support.
Philippe, I think you represent the Strasbourg ecosystem.
Yes, as well. Nothing against Paris ecosystem. I've been there for 15 years, but I love the fact that in region we can do things, and sometimes we can do things faster, quicker, and at the international level as well. I would say be curious, challenge us. You have 3 companies here who wants to achieve FTQC moment in the next years. I give you an example that we have announced today with a quantum cryptography company who wants to achieve a one-shot signatures in the near future. They are going to challenge us in order to define through Mimic a blueprint for neutral atom technologies. That's where we are to assist. So please come to us.
Laurent, you are the Paris ecosystem.
No, I'm the Station F create zone ecosystem that's very specific in Les Maisons du Quantique, the first one. It's like the Ligue des Champions, Marseille is the first one. No, just joking. No, I mean, at the end of the day, what we need is end users and customers. We have seen an acceleration recently because people start to be interested because you bring value. Whatever the way you bring value, you work on something that people are aware. And we've seen this shift in the industry leaders, in the enterprise. At the end of the day, don't care if you're from Paris, from Berlin, from Munich, from Baltimore, Maryland, or whatever. What I need is your use case that is quantum compatible. That we do things within the next 2 years. I'm not waiting for the FTQC, LTQC, NISC, whatever. I'm just waiting for, can I solve a problem with existing resources that I have at hand, period. Because that's what is going to make the business thrive and make us all successful in quantum. So that's really my point. It's today is the day. Tomorrow I don't care. Today is the day. And I'm using all the resources I have at disposal to make this happen. And emulators are one way. Hardware is the ultimate way. At the end, I need your hardware mode. The sooner the better, no pressure. But I will need emulators to have the complete chain working.
Maybe we have 3 minutes left, 1 minute for each. What is your next step in emulation or in quantum computing? Maud?
Well, I said it. Our next step is to have a description of accurate description of the noise model of the qubits. But maybe what I wanted to finish with is that we need problems. We need use cases that you don't know how to solve today. And this is not necessarily, oh, you know that it's going to be that quantum algorithm, but something that is hard for you. And then we can work out whether quantum computing is going to help. And maybe the takeaway message is that we now have all the tools that are needed to check whether we can find a solution and whether we can be faster in quantum. So the ecosystem is getting structured, and by doing so, by bringing some problems and sharing them with us, you don't need to be very creative. Just come with some persona of your problems, but we can really develop the industry and solve real problems, and you drive the direction of the technology. That's what Octave was saying. Just invest a little bit of time so that it takes the whole industry forward.
Philippe?
No matter where you are in your journey, if you are just starting to make your first circuits, or if you have already needs for emulation on state vector, or you want really a robust tensor network to do a digital twin, for instance, of your machine, or to perform a few hundred qubits on your algorithm, the things here for us is to help you to be there. And one of the challenges we have is to, of course, enable your developers to get educated on. So one of the crucial things we all need to do is to have the developer engineering school to get access to this technology, and the ecosystem, the industry needs to have a demand for it. Otherwise, the engineering school are not going to make the efforts. There is not enough school in France, for instance, working on a quantum engineering program. Of course, that's good at PhD level, postdoc, etc. It's easy to find people, but at the engineering level, we are still missing this qualification. And one of the things I may want to change in the near future is every year to have a number of developers in the quantum qualification.
Laurent? Last word.
Quantum is today, not tomorrow.
Thank you. I think we can definitely say that emulators are not just patch waiting quantum computers, but definitely tools to learn and to reduce risks and design scalable solutions today. Thank you very much, all of you.
I just wanted to bounce back off what Octave said. To minimize the barrier entry, the government has launched the Aquila program today, and that is with OVH, where you can have access to the machines and some emulators. So it's once again a step towards making it closer.
Okay, thank you very much.
Merci.
I let you go.